In this video, we're going to look at examples of using the vertical line test to determine if a given graph represents a function that relates y with x. That is, one x value giving you no more than one y value. So let's have a look at the first example. So this is example A. Okay, we have what looks like a parabola. Okay. Now the vertical line test, it's actually quite simple and it's actually quite clever, in fact. Take a vertical line. I'm going to use a ruler here to represent a vertical line. The vertical line has to be parallel with the y-axis, of course, or perpendicular to the x-axis. Sweep the vertical line, or the virtual vertical line, sort of from left to right. And anywhere where the vertical line intersects with the graph more than once, that means that for a given x value, you in fact have more than one y value as possible outputs. So in the case of the parabola, there's really nowhere on the parabola where the ruler, which represents our vertical line, intersects with the graph more than once. So at this part of the graph here, it doesn't intersect, well, at least from what we're shown, it doesn't intersect at all. I mean, it will if I was to continue the graph on, but it doesn't matter. It doesn't break the rule of a function, or what constitutes a function. And anywhere along, there's only one point of intersection with the ruler. So this one is a function. Okay, what about part B? Okay, that just looks like a straight line. Again, if we a straight line that's got a sort of a gradient of sorts. Of course, it will have a gradient. Looks like maybe the gradient of 1 if it was drawn to scale, but we don't even know what the scale is, and it doesn't really matter. Again, take our vertical line, okay, and if we sweep it from left to right, or right to left, doesn't really matter. Let's just go from one side to the other. Okay, check to see if it intersects with the graph more than once. Once is fine, of course. That's what a function is, isn't it? One x value giving you, at most one y value. This one clearly passes as well. So this one also, we can give it the tick of approval for being classed as a function. How about part C? Okay, this one's a circle. So if we sweep the ruler or the vertical line, okay, from one side to the other, we can see that there's multiple points of, well, I wouldn't say failure, but multiple points where the rule of what constitutes a function is broken, in fact. So if you just take in fact, let's take the y-intercepts. When x is 0, okay, we have two possible y values that result. So one of the, or the previous video I made on the function machine, that's like, we have one x value in, here's our function machine, but we have two possible y values, y1 and y2. That's not a function. This is a relation, okay, but not a function. So this one is not a function. And you only have to find one point, or one x value, or one input value that results in more than one y value, and it's not a function. Unless we restrict something, or we put a restriction in place of sorts, from what we can see here, this is not a function. Okay. What about, say, part D? Okay, it looks like a sideways cubic curve. So kind of looks like sort of the inverse of a cubic curve of well, at least what it looks like, sort of the cubic curve that's sort of shifted around. Anyways, let's get our vertical line and sweep it from sort of left to right or from side to side, keeping it parallel with the y-axis, of course. And again, we can see another point of failure here in terms of being defined as a function. This graph breaks that definition. So this graph doesn't adhere to the definition of a function. We have a particular x value, okay, that gives you multiple y values as a result. So y1, y2, y3. Okay. Elsewhere in the function, or elsewhere, I was trying to say function, elsewhere on this relation, okay, it looks like a function. Okay, so if we take this point here, we can see clearly that one x value restricted in this region, one x value here gives you one y value, which is nice. So if we restrict the x values, we still call that domain. If we restrict the x values to a particular region of this graph, then sure, we can define a function in a particular area. But if we're just looking at the graph as a whole, we've got, all you need is one point of failure. That's enough. This is not a function. Okay, we can get clever with this and say, oh, but hang on a moment, we can restrict the graph to just, you know, the left-hand side or the part, you know, sort of to the right of the y-axis or whatever. We can look at that later on. But just for the purposes of determining, you know, using the vertical line test, if it's a function or not, this one's not a function. Look at part E. Okay, well, it looks like we have what we call a piecewise function. It's sort of two parts, sort of separated, two branches or two parts of this function that come together to produce a complete sort of, I'm calling it a function. You know it's going to be a function, of course. Get our vertical line and just move it sort of to the, from the left to the right. We get to this point here. Notice that at the end point of one branch, okay, one branch there, we straight away go down to the open circle here, which means that this value, whatever this value is here of x, let's call that x1, if we put in x1 into the function machine or to the input, as the input, the output is, let's call it here y1. Okay, can't be the open circle, because an open circle means that the function cannot, or the equation or the relation cannot take on this value. The y value can't be that value there. And of course, moving the ruler further along, you know, everyone's happy. All right. This is a function. Okay, so we're okay with that one as well. Let's have a look at part F. Now part F is very similar to part E. There's one small change. You notice that the open circle, okay, so this was the open circle here, now has become a closed circle. So that means then that there's a point, let's call this x1 again, some point x, input x1, where it's possible to get two different y values occurring simultaneously. So we could have a y1 occurring as an output. We can also have y2 occurring as an output as well. That's not a function, at least not in this area anyway. But because we're looking at the graph sort of as a whole, we cannot say that this graph represents a function, again, unless we restrict the x values to particular regions of the graph. So this one is not a function. Okay. And lastly, I thought I'd throw this one in. What about this? It's a vertical line. Function or not a function, a relation. Let's call this point x1, sort of on the x-axis there. So this is a vertical line. Moving our ruler, sort of from left to right. The line happens to be parallel with the ruler itself. In other words, the line is actually, or the ruler is on the entire line. That's every point. So in other words, when we put in an input x1 into the function machine, how many possible y values result? 1, 2, 3, 4, 5, infinite, actually. So this one well and truly breaks the rules of a function, so clearly not a function. In other words, give me a value x1, I've got lots of y values as a result. So it's not one input, one output. This is one input, infinite outputs. So clearly, again, not a function there. Thanks for watching, everyone.